more than a year ago. Two shoebox-size satellites launched into orbit on a mission to study how heat moves from Earth's sun-drenched tropics to its chilly poles. That mission, NASA's PREFIRE, was set to last about 2 years. But now, just past its first birthday, the mission has been extended through September 2026 and is broadening its scope to look at the entire globe. And it is already returning unprecedented data about how Earth loses heat and potentially why some areas get hit with storms more often than others. Earth's poles play a critical role in regulating the planet's temperature. Because they absorb energy that starts out in the tropics, here's a closer look at how NASA's Polar Radiant Energy in the Far Infrared Experiment, or PREFIRE, is shedding light on Earth's polar regions and beyond. At the core of the mission is a pair of advanced spectrometers built by NASA's Jet Propulsion Laboratory in Southern California. They measure wavelengths of light in the far infrared range of the electromagnetic spectrum and are sensitive to 10 times more far infrared wavelengths than any similar instrument. This is important because different molecules absorb and emit different wavelengths of light. So, by measuring what wavelengths reach the satellites, scientists can identify what molecules they came from and how much of each molecule is present. When Earth absorbs energy from the sun, much of it ends up in the tropics. Winds, weather, and ocean currents then carry that heat toward the poles, which receive much less sunlight directly. As the heat moves, it's constantly being exchanged between the atmosphere and surface. At the poles, the ice, snow, clouds, and soil, among other parts of the polar environment, emit some of that heat into space, much of it as far-infrared radiation. The difference between the amount of heat Earth absorbs at the tropics and radiates out from the Arctic and Antarctic is a key influence on the planet's temperature, helping to drive dynamic systems of climate and weather. Launched in spring 2024, the two PREFIRE CubeSats have been measuring how much heat the planet emits into space from the Arctic and Antarctic as part of its prime mission. But although the satellites circle the globe, taking readings as they pass over both poles, the science team has concentrated their analysis on the poles for this phase of the mission. Going forward, they will expand their work to include data from the rest of the world. The PREFIRE satellites show that at these longer wavelengths, the amount of radiation going into space can differ from one type of ice to another by as much as 5%, said Brian Doreen, PREFIRE's project scientist at JPL. Measurements that look at the same areas but with shorter wavelengths do not show this difference. This detail matters because the amount of heat a particular type of ice or cloud cover emits can affect whether rain falls instead of snow, for instance, or how long snow remains on the ground. Those factors have ripple effects on local weather and climate, influencing things like the growth of plants and the timing of animal migrations. Since launching in 2024, the satellites have made several intriguing discoveries. One is that the ice crystals in clouds at the North Pole are on average smaller than those further south. That's thought to be because the clouds at the North Pole are made of more supercooled water, which makes smaller ice crystals. The size of those crystals affects how efficiently they reflect or absorb energy from the sun and also how quickly they fall from the sky. These details, in turn, affect weather and climate patterns, both at the pole and further afield. Another discovery is that cirrus clouds, which are high-altitude clouds made of ice crystals, emit substantially more far-infrared radiation than previously thought. That finding may have implications for understanding the role clouds play in Earth's climate system. Clouds can have a warming or cooling effect depending on their altitude and composition. High-altitude clouds that reflect sunlight have a cooling effect because they reduce the amount of energy that reaches Earth's surface. Meanwhile, lower-altitude clouds that trap heat near the surface have a warming effect. Cirrus clouds, which are high-altitude and mostly made of ice crystals, reflect sunlight and therefore tend to have a net cooling effect, but they also emit heat. Until now, it wasn't clear how efficiently they emitted heat. It turns out they're more efficient at emitting heat than scientists expected, which could mean that they might not be as effective at reflecting sunlight as they are at emitting heat. More research is needed to confirm this, but if it's true, it would suggest that the overall effect of cirrus clouds on Earth's climate might be smaller than scientists have assumed. Cirrus clouds also have a direct impact on weather in the form of precipitation. Another interesting finding from the mission is that the satellite spotted previously unobserved cirrus clouds over the Antarctic Peninsula during the winter of 2024. These cirrus clouds were associated with storms that led to record-breaking rainfall in parts of southern South America. Storms like these are known as weather bombs or explosive cyclones. They typically form when a low-pressure center rapidly intensifies, causing an influx of energy and moisture to be released into the atmosphere. Understanding how these storms form and evolve is crucial for predicting their intensity and impacts. And cirrus clouds, even though they don't produce precipitation themselves, may play a role in the development of more intense storms. They can enhance the growth of deep convection, which refers to the vertical movement of air that forms clouds and precipitation. In other words, they may contribute to the formation of bigger storms with heavier downpours. By studying these clouds, scientists hope to gain a better understanding of the role they play in the life cycle of storms. In addition to improving weather forecasts, PREFIRE's data can help researchers understand how Earth's polar regions respond to a changing climate. The poles are warming at a rate that's twice the global average, and understanding how they exchange energy with the rest of the planet is critical for projecting how they will change in the future. For example, as temperatures rise, more snow and ice may melt, leading to changes in the amount of energy that is reflected or absorbed by the surface. This can affect regional and global climate patterns, including sea levels, weather extremes, and ocean currents. By studying these changes, scientists can develop better models of how Earth's climate system works and make more accurate predictions about how it will change in the future. The satellites are in what's called an asynchronous near-polar orbit, traveling near the poles with each pass, but hours apart from one another. This provides 2 snapshots of the same area over time, enabling the mission to capture phenomena that occur on short times, such as cloud cover's temporary effects on the temperature of the area beneath it. Because we have 2 satellites looking at different times, we're getting an incredible amount of data, said a co-investigator on the mission based at JPL. If we had only 1 satellite, we wouldn't be able to see these changes over time. Having 2 satellites makes all the difference. Over the next few years, the PREFIRE team plans to analyze data from the entire planet. Then they'll be able to study how energy moves from the tropics to the poles, as well as the role clouds play in that process. Ultimately, this data will be incorporated into weather prediction models to improve forecasts and improve our understanding of how moisture circulates, which affects where storms form and how precipitation moves around the world. The findings from the extended mission could also help scientists better predict extreme weather events like hurricanes and floods, which can cause significant damage and displacement. By understanding the factors that contribute to the formation and intensification of these storms, scientists can develop more accurate forecasts and help communities better prepare for the impacts of extreme weather. The PREFIRE mission could also help advance our understanding of planetary atmospheres and climate change on other planets. The PREFIRE mission is poised to make significant contributions to our knowledge of Earth's polar regions and the global climate system.